Hi everyone, I hope you enjoyed the last episode we had of the podcast with David Sinclair. I had a ton of fun doing that, and I just want to connect again with Stella, our editor, who has a PhD from UCSF in pharmacogenomics, and you're a bit of a nomad, Stella. Where are you now?
Hi, Gordon. I'm working this week from Nairobi, Kenya.
Wow, fantastic.
So, Gordon, I really was fascinated by the experiment that David described in his lab, where they were trying to delay senescence. Well, they actually delayed senescence by damaging mouse optic nerves, and they observed a nerve cell regrowth. I think that's really incredible. And I'm curious, what can we learn from experiments like this?
Well, Stella, I mean, picture this. Imagine you're young 25, 30-year-old scientist, and you're looking down a microscope at some tissue sections, in this case from an eye that essentially has lost its sight. And suddenly you realize that what you're looking at is regeneration. You're actually looking at the power of being able to turn back the clock in certain cells by this whole field of regenerative medicine, where you can change the fate of cells and take them back to a younger, more youthful state. That's nuts, right?
Yeah.
How inspiring is that? And I'm sure it's just inspiring many, many scientists across the world to replicate those experiments and think about how to take them forward.
Yeah, it's very exciting. And it brings me to my next question. I've been noticing this theme, this shift to discussing aging as a treatable disease. I think in my research, obviously Alzheimer's disease is a disease of aging. And, we have the age of onset being 65. And most times when I was doing experiments, I would have it age as a factor. But I'm also seeing that there's some labs at UCSF that are actually focused on aging. And I think it's really interesting. So what does this, mean for us treating aging as a disease?
So, I'm an optimist, I guess. And I think that what we're seeing in the lab in animal models is telling us something about ourselves. So, of course, it makes me wonder, is this possible that we can have interventions in aging that can take us beyond what we currently see? And what we currently see is not great, right? And, most of us are going to have age-related diseases, whether it's heart disease, neurological disease, and it's not great. And we can do better, and we know we can do better because there's individuals in our population like centenarians who are able to bypass all this and live a longer life and a more enriched life as a result of potentially their genes. So that's what we're looking for. We're looking for interventions like this that can take us to that future.
Awesome. So who are we talking to next?
Well, we're going to talk to Judy Campisi, who actually occupies the office right next to me, so I can knock on her door and start the interview. So it's a real privilege to get to spend some time with her. She's known for her amazing work in cellular senescence and its contribution to aging and all sorts of diseases. And she's a super person to talk to. I can't wait.
This is going to be good.